Energy transformations. How one type of energy can transform into another type. At this level of physics, the interactions we are going to explore follow this pattern. A whole bunch of reading summarized into a nice flow chart right here for you. So chemical energy can go down to kinetic energy. So you can transform from chemical to kinetic. You can transform from chemical to thermal. You can transform from chemical to light, or chemical to sound. You can go from kinetic energy to sound. You can go kinetic energy to elastic potential energy, gravitational potential energy, electric potential energy. Note the energies in this flowchart are color-coded by their classification: chemical, mechanical, or dissipated. There are other classifications such as internal energy, which are chemical and thermal, which is any energy possessed by the molecules of a substance. But just like we had internal forces, beating heart of the track runner, not affecting the motion, the internal energies can kind of be forgotten about unless we're focusing specifically on those smaller particles. Chemical energy becomes kinetic energy when a person walks, runs, or climbs. We take in calories, and then that's our chemical potential energy stored in our fat cells. Then that chemical energy is transformed into kinetic energy when the muscles start doing work to move our body. Chemical energy becomes kinetic energy as gasoline burns in a car. Chemical energy becomes electric energy when a battery is placed in a closed circuit. Not relevant to us, but certainly interesting to a lot of you. Rotational kinetic energy can become electric energy through the use of a generator. Likewise, an electric motor can change electric energy into rotational kinetic energy. So we're not going to talk about these too much at this level. When an object speeds up as it moves to a lower height, gravitational potential energy becomes kinetic energy. When an object slows down while moving to a higher height, then we have kinetic energy becoming gravitational potential energy. How many different situations can this happen in? It's countless, for sure. But you should be able to think of lots of examples, and we have already done lots and lots of situations where these two energies are transforming into each other. Kinetic energy becomes elastic potential energy, or spring potential energy, when an object slows down as its motion causes a spring to expand or compress. Also, spring potential energy becomes kinetic energy when a spring is going back to its equilibrium point, causing an object to speed up. Kinetic energy can become thermal energy through friction. As friction acts, friction takes away kinetic energy, causes the object to slow down and transforms that thermal energy. So it takes away kinetic energy and turns it into thermal energy, which heats up the atmosphere. Looking at it at a molecular level, the block is made up of blue molecules, which at first don't vibrate a whole bunch. The block is cool. Floor is made of gray molecules, which are fixed in place. For this animation only, and obviously it's not true. As the blue block slides across the floor, molecules bump into each other. Blue molecules bumping into floor molecules makes them vibrate more. As blue molecules bump into each other, all of the block's molecules vibrate more, indicating the block is getting hotter. But the block as a whole slows down, so its center of mass is losing velocity. The block's center of mass's speed decreases, and the molecules pick up individual kinetic energy as they wiggle randomly, so the block is gaining thermal energy. See that energy transformation. So it starts out moving fast, and the molecules are still, and then as it slides across the floor, it's slowing down as a whole, but the individual molecules are speeding up because they have more kinetic energy, more thermal energy. Another way energy becomes thermal energy is through impact. Impact occurs when an object collides with another object. Here the blue block is dropped onto a floor. The molecules of the blue block don't vibrate much as they fall, but that gravitational potential energy becomes kinetic energy. Now, when the block collides with the floor, most of its kinetic energy becomes thermal energy as the molecules begin to wiggle randomly. There's also some still leftover kinetic energy where there's a change in momentum in that bounce back up, but you see the molecules moving wildly after the collision. The block is inelastic, so it loses some kinetic energy to thermal energy and can't bounce up to that same height. If the block were perfectly elastic, it would lose no energy to thermal energy and would instead bounce back to the same height it was dropped from. This is not a real situation. If it were a real situation, then we would have some crazy bouncing going on. Certainly a lot easier to play basketball. We can actually see the kinetic energy become vibrational energy of the molecules of this tennis ball as it bounces off the ground, shown here in slow motion. You see the ball vibrate after the collision? This is kinetic energy being transformed into thermal and sound energy. So, kinetic energy becomes sound during impacts. When a hard object strikes another hard object, a sound wave is created. When this happens, the two objects' total kinetic energy is decreased, and the missing energy becomes a sound wave. Sound energy. We don't talk a whole lot about sound, but it's good to have some understanding of the world around us, so some bonus physics for you. The energy in the form of sound as long as I can hear the sound. When I can't hear the sound anymore, then the energy must now be some other form of energy, right? No! The energy is still sound energy, but the sound has traveled past you. You can hear the sound as the wave passes your ears, but you don't hear the sound anymore once the sound wave has passed you.